this question, we're going to compare the mean of a population with the mean of a particular sample. So this question, I have the formulas up here. We'll use one of these two. The big change here, chapter 7 versus before, is that you're dealing with not just one item sampled, but in this case, a sample size of 41. And that means that normally the standard deviation was just S, but now because we have lots of items, the standard deviation drops. So we use the S divided by square root of N, which is the sample size. So that's going to be the difference, chapter 7 versus before. And here we have computers. The laptop normally has a mean of 3.7 years and a standard deviation of 0.6 years. And this shop owner had 41 laptops in the past, and his mean replacement time was 3.5 years. So that is less than 3.7 years. But the question is that suspiciously less? Is that so much less that these are a bad bunch of laptops? So what we're going to do is compute the probability that this actually occurred. So compute the probability that 41 randomly selected laptops had a mean replacement time of 3.5 years or less. So which of these should we use? Let's just think what we're asked to compute, find the probability. So we don't know the probability. So looking at these two, norm.inverse, this P stands for probability. So the inverse function requires a probability, which is exactly what we want to compute. So we're not using norm inverse, we're using norm dist. So let's go ahead and compute this probability. I'll just label it with P equals norm.dist. I'm using the tab key. So here, X is the value we got. There's technically two means. There's a 3.5 years or less. That was the mean replacement time of the sample. 3.7 years is the mean replacement time of the population of all the computers. So X is the mean of the sample. So that's the 3.5. Now the mean is the mean of all the computers of the population, which is that 3.7 up above. Now standard deviation, it's tempting to do 0.6. This is going to be incorrect, but I'm just going to go with it. You'll see what happens. And cumulative, usually we're going to go true in this section. We want or less. So the or less is cumulative. So this is the probability, but and this is the correct answer over here. So it's different than the correct answer. Why is this so much higher? Because this is the probability that one laptop has a replacement time of 3.5 years. We want to know the probability that 41 laptops have a mean replacement time of 3.5 years, and that's why we take the standard deviation divided by the square root of n, which for this problem was 41 laptops. And what this does, it takes this 0.6 and divides it square root of 41. Actually, it says on the screen, it's a little bigger than 6. So it's going to take this standard deviation and basically drop it by about 6 times as small. So it makes it quite a bit smaller. And when that standard deviation goes down, it means there's less variability. And in this case, it means the probability is much smaller. So that's the probability right there. The right answer in MyUp Math is here on the right. It's just rounded. It's the same number, just rounded. So that's how to get the probability. The second part is we have to decide, does it appear the computer store has been given laptops of lower than average quality? So how do we know yes or no on this? Basically, if this probability is suspiciously low, so how low is suspiciously low? That's a good question, but basically we take, so this original question was broken. I just went and fixed it. The hint I put down here in yellow. Our probability, if I turn it into a percentage, is 1.6%. It's very small. And is this an unusual outcome? So if it's less than 5%, it's an unusual event. So the answer would be yes, it is unusual. So that laptops are likely lower than average quality. Now, that's the end of this question, but I want to talk briefly about what would make this less unusual. So these laptops lasted 3.5 years and there was 41 of them. So let's say instead of there's 41, there was only 4 laptops we tested. Now all of a sudden, 25% chance this outcome occurred, and this is no longer suspicious or unusual. So if the sample size was much smaller, we would not be able to conclude this was unusual. The other way this could have changed is if, let's say they lasted, instead of 3.5 years, if they lasted 3.6 years, so very close to 3.7, now all of a sudden the probability is up to 14%. So this is no longer suspicious or unusual. So when your probability is very small, meaning less than 5%, that's unusual. And in this case, you would say the laptops are lower than average quality if it's unusual. But again, if you have more than 5%, you would say this is just bad luck, basically.